All right, so last time we talked about trig ratios, and really we just kind of talked about the basics. Okay, we just kind of talked about what they were, how they were used in regular triangle, or not how they were used, but like what they represent in each type of right triangle. What we're going to be doing today is we're going to be learning how to use those, right, to find missing pieces of triangles. Because if we look at, for example, number 1, right, you can see that we have one side and we're asked to find the missing side, right? But there's too much information. Like, we could try using the Pythagorean theorem, but we have two missing sides essentially. So the question then becomes, right, how are we going to solve for that missing side? Okay? So the way that we can do that is just by setting up our trig ratios just like normal. Okay? So please remember, right, that phrase that I asked you to remember, and I might even write it up here for you, or I might even write it up here for you guys, or if I were you. So, ka, toa. Okay? And that just kind of tells you which trig ratios to use when. Okay? So sine, so S, is opposite over hypotenuse. Cosine, adjacent over hypotenuse, and tangent is opposite over adjacent. Okay, so if we're looking at this very first problem, right? The only angle we're given is this one right here. Okay, so if I'm going to set up a trig ratio, I mean, I could go ahead. I could actually use the other angle too if I wanted to, but that requires more steps just to do essentially the same problem. Okay, so instead, what I'm going to do is I'm just going to use this angle as my reference angle. So again, that means that I'm standing here at this angle and I'm looking inside the triangle, okay? So, if I'm doing that, which trig ratio do you think I should use to set this up right now? Should I use sine, should I use cosine, or should I use tangent? Anybody?
Sine.
I should use sine. Why sine?
Because it's opposite over hypotenuse, and you have the x and the 20 there.
Right, because if I'm looking at this, right, the two sides that I kind of really have or have in question, right, is I've got this opposite side, right, and I've got the hypotenuse. Remember, the hypotenuse, no matter what angle I'm standing at, is always the side opposite 90 degrees in the right triangle, okay? So if this is my hypotenuse, this is my opposite side, right, we would use sine, because sine is opposite over hypotenuse. So how I would set this up is I know that sine of 67 degrees is going to equal opposite, so x, over a hypotenuse, which is 20. Okay? Now the key thing to kind of remember here, right, is that remember, this is a number. Right? This is just kind of a placeholder for a number. Right? The 67 is not anything that we really work with. It's just the reference. But sine of 67, it does equal a ratio, and that's kind of what we talked about the last time. Okay, so this is going to equal one number. So that means that I can move it around and multiply it, divide it, and stuff like that, just like I could any other number. Okay. For this exercise, I know I have it up here as tenths, but we're going to round to the nearest hundredths. Okay. So what I can do here, right, in order to solve for the missing side, is I can do just like I normally would in any algebraic problem. I can multiply by 20 here to get rid of these, and that would mean I have to multiply by 20. So essentially what we're left with is 20 times sine of 67 is equal to x. Okay? And now you're probably going, well, that doesn't help me at all. Right? Because realistically, that's not, it's not anything that I know how or anything like that. I don't know what sine 67 actually equals off the top of my head. And let me tell you, it's not exactly something that you can easily calculate off the top of your head. Okay? So today I'm going to teach you kind of how to use a calculator in order to solve these. Okay? And you're probably going, well, duh, I know how to use a calculator. I just type in buttons. But trust me, there's actually a really, really fine point when you're using calculators, especially for trig, right, that you need to keep in mind, because not all calculators are the same, right? And if it's in the wrong mode, you're not going to get the right solution, okay? So rather than trying to sit here and explain to you how to use it on your calculator, or how to use it on the calculator on your phone, or how to use like normal standard like graphing calculator or a scientific calculator, we're going to use the Desmos scientific calculator. Okay? I'm going to teach you guys how to use that one because A, it's probably the easiest, right? And B, you're going to have access to it all of the time. Okay? So, what I want everyone to do is go to desmos.com/scientific. Okay? And truth is if you download this on your phone, there's actually even an app for it. Okay, so you can even have this on your phone if you wanted to. Okay. Now, when you go to desmos.com/scientific, okay, I'm going to pull up my app. This is kind of the screen that you're going to see. Okay. Now, it has a whole lot of features on this. And I can, like, if you're using your Chrome, you can actually type in your math problem on here and it'll work just like normal. Right? So it's a calculator that you have easy access to. Okay, but the key part of this, and I know you guys can't really see what I'm pointing at with my pencil, but I'm going to try to move it so you can kind of see the important part of this. Okay, so every single calculator has 3 different modes. It's got science, or it's got radian, degree, and I guess scientific. Okay, or something else. It's usually called something else. Okay, the key part of this, if we're working with degrees, which we are, right, it needs to be in degree mode. Okay. So sometimes if you're using like an older calculator, if you can kind of see what's switching back and forth here, right? That's the way that kind of indicates the mode. Now, there will be a time in Algebra 2 that you'll use radian, but for here on, or for the sake of our class, we're gonna our calculator, we need to make sure it's in degree mode. Okay, very, very, very important. Okay, so if you're using like a calculator at home, or one of those like the handheld calculators, you need to make sure it has the letter D or the words DEG somewhere on the screen, because if it does not, it is not in degree mode. Okay, so you need to make sure that it says that. Super important. Okay. All right. So now when we're going to solve this thing, we're just going to type it out just like we had it. So the problem that we had, right, was we needed to say, well, what's 20 times sine of 67? Okay. I go back. So I'm just going to type it just like I have it. I'm going to go 20 times, and then you can type SIN, but I like using the function. So if you go over, look to the left-hand side, right, there's got sine, cosine, and tangent in the bottom left-hand corner. I would use those, and the reason why is because it automatically puts up the parentheses. And I know that sounds weird, but it's very, very important. And I'm a very big stickler when it comes to using parentheses for these things. Okay? So I type sine, and then I just type in my degree, which is 67. And my answer pops up on the right-hand side. Okay, and I think I can move this up. I thought I could. Okay? So 20 times sine of 67 is 18.41. Okay? So for this purpose, I know that x is about, oops, sorry, that should be red. About 18.41. Okay? Now, before we continue on, what I want you guys to do is I just kind of want you to get some practice using this graphing, or using this calculator. So I'm actually, oh shoot. Yeah. So I actually have that other worksheet that you were asked to print. Where did you go? Okay. For right now, all I want you to do is tell me the values of the top 9. Okay. And there shouldn't be a whole lot of math going in. It's literally just kind of typing it into the calculator and see what it says. Okay. So I'm expecting this should take you guys just a couple of minutes. Okay. So please go ahead and try this out for just a couple of minutes, and we'll come back to the other worksheet. Okay. All right. So, who can tell me what we got? So what's cosine of 73?
Zero 0.29.
0.29?
Yeah.
Okay. All right, what about cosine of 74.5? Cosine of 74.5. Come on, guys. What do we got? 0.26. It's more like about 0.27. Okay? Now we're rounding to the nearest hundredth. Okay? What about tangent of 81 degrees?
6.31.
6.31. Perfect. Sine of 59?
What is 0.86?
0.86. Yep. Sine of 33? Sine of 33 degrees?
0.54.
0.54. Perfect. Okay. Tangent of 75 degrees?
3.73.
3.73. Perfect. Tangent of 38.9 degrees?
0.81.
Perfect. 0.81. Tangent of 57?
1.54.
1.54. And cosine of 17 degrees?
0.96.
0.96. Thank you. Okay. So again, the whole idea about this exercise is just to kind of get you used to using your scientific calculator for typing in these values. And the other part is I wanted you to see that these values are set. Okay? They are set in stone. There's no, like, if I type in cosine of 73, I shouldn't expect to get anything else besides 0.29. The other part I wanted you to see, which might be a little bit interesting, and again, I'm not going to focus on it too much because, where's it at? I'm not going to focus on it too much just because of timing this year, but one of the things I want you to notice, right, cosine and sine, they're all between what values? They're all between
1 and 0.
Yeah, 0 and 1, right? So cosine, sine are between 0 and 1, okay? But what about tangent? Tangent can be anything. Or if we notice, it's the only one that's greater than 0. Now there is one part though where it's less than or greater than 1, but there's one part where it's less than 1, but that means it can be pretty much anything, right? Okay? That's one of the things that I kind of want you to notice. All right, so let's go back now. Now that we know how to kind of use our calculator to type in these values. Oh shoot, that's the wrong button. Let's go back to. Okay, this one. Okay, I'm gonna do one more example with you, and then I want you guys to kind of try to use this, right, or use these ideas to try to solve numbers 3, 4, 5, and 6. Okay. So for number 2, right, looking at my triangle, which of the trig functions do you think I'm going to use here to try and set this up? What do I use, sine, cosine, or tangent?
Cosine.
Why cosine?
Because it's adjacent and hypotenuse.
Perfect, because if I'm standing here at this reference angle looking in, right, the side I'm given is the adjacent side, and then again, this side is always the hypotenuse. So this tells me that cosine of 41 degrees is going to equal 19 over x, because cosine is adjacent over hypotenuse. Okay? And just like tangent is opposite over adjacent. Okay? So cosine of 41 is equal to 19 over x. This is new. Now we have to try and solve for x that's in the denominator. How are we going to do this? Anyone have an idea how I'm going to solve this? How do I isolate x when it's in the denominator? Venture a guess. Okay. Well, here's a one way to kind of look at it. There's multiple ways that you can kind of look at it, but this is just one. So if I imagine cosine of 41, it is just a number, right? But so any number over 1 is still that number. But now what I've created here is a proportion. And how do we solve proportions?
Go straight across.
That's when we multiply fractions, we multiply straight across. But when we have proportions, we have that equal sign in the middle. We have to do something else.
Cross multiply.
We have to cross multiply, or cross product property. Okay? So I'm going to take cosine of 41 and multiply it by x. I'm going to take 1 and I'm going to multiply it by 19. Okay? So what that leaves me with is x times cosine of 41 is equal to 19. Again, right, you're probably looking at this going, all right, well, I can't multiply a variable like cosine 41. It's still a number. So I can still divide it, the whole thing, by cosine of 41. Okay? I can divide both sides. And when I do that, all right, that eliminates these here, right, but it creates another ratio on the other side, something that I can actually type into a calculator to solve. So I get that x is equal to 19 over cosine of 41. Okay? Now I want you guys to type that into your calculators and tell me what's the approximate value of x. Type 19 divided by cosine of 41 and tell me what you get. Anyone?
25.18.
Thank you. About 25.18. Okay? 25.18. Okay. So I'm actually going to pause this video. I'm actually going to create 2 videos out of this. And I want you guys to just work through the next couple of problems. I'm going to give you about 5 minutes to get problems 3, 4, 5, and 6 done. Okay? About 5 minutes to get 3.5 and 6. And then we'll start again and we're going to talk about one more idea.